Hey everyone, this is Darshan Senthil, and in this video we're just going to be continuing on with linear equations. And in this video we're just going to be talking more about slopes, the slopes of linear equations. Now this is a pretty key concept because slopes are probably the most important part of linear equations. It's the thing you'll be asked to find more often than not. So this is going to be a pretty interesting video for you, at least I hope so. So let's just go back to defining what a slope was. So the slope is simply the part of the linear equation used to determine how the line rises or falls. So for instance, if you had this like hill over here and you were riding your bike, like 1 second, sorry. So there, Leonardo da Vinci at work here, take notice. Okay, so assuming you're riding my wonderful bike up this hill, you'd find it hard, right? Because this hill is sloped in a way that makes you have to put more energy into riding up the hill. But similarly, if I made you cycle up a hill like this, again Leonardo da Vinci at work here, it would be a lot easier, right? Because this hill is not sloped as much. Now, what tells you how much these hills are sloped? Well, that's what the slope does in a linear equation. That simply tells you how much the line is sloped, whether it's sloped up or down, or whether it's sloped steep, or whether it's sloped shallow, I guess. So that's all the slope tells you in a linear equation. It tells you how the slope line slopes. So you may also hear that the slope is called the rate of change, ROC, as I may have mentioned in the previous video, and that is simply because it represents a change in data represented on a graph. Like for instance, you may see a lot of companies have stuff like this, like in January they have this much, in February their cash is like this, then March is like this, April is like this, then May is like this, June, July, August, September, October, November, so on and so forth. And that, what do you see about this? So if they had this much money in January and this much money in February, it's quite a change, right? So the line has sloped a little bit. The line representing how much money they have has sloped. That's why it represents a change, a rate. It's a rate of change, the rate of how much their cash is dropping and rising. That's all that. That's why it's called rate of change. So yep, that's how that is. So now what I'm going to show you today is how you can use slopes and how the slopes of different types of lines are related. Like if you've been to a geometry class, you'll know that there are a lot of relationships between certain lines, and we're going to just discuss how their slopes in linear equations are also related. So to help us do this, I've made this little table over here. So first we're going to go over the type of lines, then we're going to do a little sketch to help us visualize things better, and then we're going to do the linear equation relationship between them, so how their linear equations are related. So we're just going to start off with normal, any two regular lines. So let's just draw two lines. You can do really anything, like one can go like this and the other can go like this. It doesn't really matter. And yep, let's draw some arrows, and they have a point of intersection also, that's right over there. So these lines they have different slopes obviously, but there's nothing truly special that relates these two lines if you look at it. So this guy may have an equation of y equals negative 1/2 x plus 2, and this guy may have a slope of negative was y is equal to 2x, or rather, yeah, 2x minus 3. let's just make up something there. Is there any particular relationship between these two equations? Not quite. So there's just no particular relationship that they have. Of course, you will sometimes get lines that have certain types of relationships, but between any two just like normal lines like these, you won't have any relationship. So next we're going to talk about parallel lines. So what are parallel lines? Parallel lines are simply lines that will never intersect. They go in the same direction, and wait, to do this I'm just going to try something else. They just never intersect. Wait, yep. Let's drag this out here, and yep. So they will never intersect at all. They will just keep going on like this and like this. And a good example of parallel lines are railroad tracks, like those two things on the sides where the crossbars connect. Like those things, they will never really intersect if you look at it, because if they come close to intersecting, then the train's going to skid off course and crash, killing millions. So we wouldn't want that, would we? So that's why parallel lines are good in this particular case. So let me just give you a little way to visualize the parallel lines. I'm just going to put them on a graph. So what do you see is common between these two parallel lines? Well, obviously they're parallel, but what else do you notice? They're traveling in the same direction, but from different starting points, right? So this guy may start over here, and this guy may start from somewhere down here, but they're going in exactly the same direction. So the relationship between the slopes of parallel lines is that they have the same slope. The same slope. They have exactly the same slope here. So this guy may be y is equal to 2x minus 1, and this guy may be y is equal to 2x minus 4. And so here you can see that they have the same slope but different y-intercepts. So they start from a different point, but they go in the same direction. So that's why they are parallel. Keep in mind that if they had the same y-intercepts, it would be the same line, so they would kind of overlap per se. Of course they probably don't in math terms, but it's an easy way to visualize it. So yep, that's with parallel lines, and whoopsie-daisies. Now let's move on to perpendicular lines. Perpendicular. Now perpendicular lines are lines that intersect to form right angles. So you can have one like that and one like that. So they intersect and they have a right angle formed over there. So that's what perpendicular lines are. Now if we to put this in a more graphic, like a graph form, you would have something like this. So they are they're going in different directions, actually completely different directions. Like this is a positive slope, this is a negative slope. This is starting from up here and going down here. This is starting from down here and going up here. So this starts low and goes high. This one starts high and goes low. So that's what perpendicular lines are, and when they intersect they form a right angle. But there is some sort of proportion to how this one slopes downwards and this one slopes upwards. So we would say that perpendicular lines have inverse slope. Inverse slopes. And by inverse slopes I mean that they have the negative reciprocal of each other. So say one line slope was 2, the other guys would be negative 1/2. So an easy way to check is that if you multiplied both your slopes, you should get -1. That's an easy way to check that you've got a pair of perpendicular slopes. So let's just give these two lines some slopes. So he could be y is equal to, let's do this guy, so that's 3x minus 1, and the other guy could be negative 1/3 x plus 3. So again, let's just make sure that they are perpendicular, so I'm going to do that in a different color. So if we multiply 3 times negative 1/3, then yeah, 3 times 3 is, so these two, this and this would cancel out, and then you're left with a negative 1. So that is how you would verify if you really had to. So that's perpendicular lines. And the next line we're going to be talking about, the next step of lines are vertical lines. So vertical lines, as you know, are lines that simply either go up or down. So they either go this way, they just go this way. So they could either go this way or this way, it doesn't really matter. So if we were to just put this guy on a graph, what do you notice about this line? If this is your y-axis and this is your x-axis, then you should notice that this line goes through every single y value there is. So hence, you would not be able to write an equation for this. You would not be able to write a full linear equation for this. So you would simply say that this has an undefined slope. An undefined slope. So this thing it goes through every single y value, so you would not be able to write this in slope intercept form as a y equals something. Instead, you would write these as x equals something, because you know where the where it starts as an x, so x number, so it starts as x equals, so if it goes through x equals 2, then you would just simply write x equals 2. If you write this, then we automatically assume that it goes through every single y value there is. So we just need to know that x is equal to 2. You just need to write something like this. If you are given a vertical line, this is all that you need to write. X is equal to 2 or x is equal to 7, anything like that. That's all you need to write. So the last type of lines we're going to be talking about here are horizontal lines. Now, as you're well aware, horizontal lines are just simply lines that sort of stretch across the horizon. So they just sort of go from left to right or right to left based on how it goes, and yeah, they just sort of go like this, and you've got that to that. And an easy way to check if you've got a horizontal line is to just sort of, you should be able to draw a sun like this over the horizon like this. Let's give that a bit of color. Okay. Yep, that's how you'd be able to do it. So if you're able to draw that, you've got yourself a horizontal line. Okay, so let's get back to math now. And yeah, so the horizontal lines, if you notice, let's put them on a graph. Okay, let's just do this in orange. You've got your y-axis and your x-axis. Notice that it goes through every single possible x value. So it goes through all the x's, but through only one y. So, and also since this line does not actually change at all, it just goes exactly the same way, this has no slope. Horizontal lines are said to have no slope because it really doesn't change at all and just sort of goes like this. And you would write these, I'm just going to sort of simplify the equation for you and just show you how exactly it's done. So, or you can also say the slope is equal to 0, or slope is 0. You could say either way. So now, assuming the slope is 0, that means these two would cancel out. So all you're left with is your b. and that's your y when x is equal to 0, or quite simply where the line passes through your x-axis, which is right there. And that's what you would write, the point where your line passes through your x-axis. So just to boil that all down, you would, let's just yeah, just get, I need some space, so we're gonna get rid of all that. So quite simply, here you could write, say 1 2, you could just like y is equal to 2, wait, no, better 2, so you could just simply write something like y is equal to 2, that's it. And that is, yeah, just because it passes through the 2 over here and you have no slope at all, so that sort of eliminates the x, and yep, that's how that works. So based on the information you've got over here, we're gonna do a couple of problems now, so just get ready for that and let's go. Alright, so last but not least, we're just gonna do a couple of problems based on what we've learned so far. And really, this is all that is you're gonna see for this, because we covered the majority of linear equations in the previous video, and this is just like to cover up the loose ends. So this is pretty much all the sort of problems you're gonna see. So this is just a few things I screenshotted from my textbook, and yeah, this is what's gonna come on. So just for the fun of it, since we have like such few problems, I'm also gonna graph this and show you how they're parallel to each other. So but first, let's just write the linear equation. So again, what we need to find when we're always looking for a linear equation, we want to find our slope, which is m. It's the first thing we want to find, and we also want to find our y-intercept. I'm just gonna write y-int, which is our b. So these are the two things we want to find. So, but first up, notice that they've given us an equation over here. So they've basically given us something over here, and they've also said write an equation that's parallel to this line over here. So when a line is parallel to another line, what should click in your head immediately? They have the same slope, right? So if this line is y equals 3x minus 2, what should the slope of our new line be? 3, right? So we know right out of the top of our heads that our new line is gonna be y is equal to 3x plus b. So that we know this immediately. So this is what we know right up front. So now we need to plug in to find our b. So again, they've conveniently enough given us a coordinate. So we're gonna plug this back in here, and we're gonna solve for b. So just gonna plug in, and so 8 is gonna be equal to 3 times 2 plus b. And if we simplify this, we can just to simplify, this is gonna be 8 is equal to 6 plus b, and if we subtract 6 from both sides, we're gonna get 2 as our b. So that will be our answer up here, positive 2. So that's how that will work. And then now our final equation, I'm going to do this in turquoise. So our final equation is going to be y is equal to 3x, put the 2 in here, plus 2. So now I'm just gonna graph these two, put them on our graph over here. So yep, let's just move it over a bit. Okay, so let's just put some stuff. So let's just graph this one first. I'm gonna do that in purple. So what is it? So again, our b up here is -2, so we're gonna start here. Hopefully remember how we go from here. So this 3 is equal to, okay, this is in blue, y is equal to 3 over 1. So this is rise over run. So we're gonna go 3 up and 1 across. So 1, 2, 3 and 1 across. 1, 2, 3 and 1 across. And now that's pretty much enough. So we're gonna put our line through these points. It's pretty... could have done this. Wait, no. I'm gonna do that again. This is not going in perfectly. Sorry, I'm a bit of a perfectionist. So yep, and let's just transform it to make it longer over here. So yep, we would have our line like this, and notice it goes through all this. And next we're going to plot in our new line, and that I'm going to do in turquoise, just the line we wrote the equation in. So we started +2 this time, which is up here, and we go same thing, 3 up and 1 across. 1, 2, so 1, 2, 3 here and here. So we're just going to draw a line through this again. And let's just transform it to make it longer, and that's about it. You can just go back here, and yep, we've got our 2 parallel lines. Notice that they are probably not going to intersect anytime soon. And also let's just check to make sure our point 2, 8 is on this line. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and what do you know, it's on the line. It's right there. That's our point 2, 8. So yep, we've done this right. So that's the first problem, and we'll also do this one over here because I want to show you a bit of both. So last but not least, we've got this problem over here, and we're just gonna find the line that's perpendicular here, because that's something that I just want to expose you guys to. So again, we're gonna do exactly the same thing as we just did. We're gonna find the line that's perpendicular here. So we're just gonna list the things that we need to find once again, which are slope and y-intercept. The slope and y-intercept, those are the 2 things we need to find. And once again, they've given us this equation. So what do we know at the top of our heads about perpendicular lines, about their slopes? They're inverse, right? They're inversed. So if our line here is y equals 1/3 x plus 3, then what's the inverse of this? It's gonna be -3, right? So our line, we know that it's going to be -3x plus a b, -3x plus a b. So we know this out of the top of our heads. Now we just need to fill in for the b, and again, conveniently they've given us a coordinate here. So once again, we're just going to plug in 1 is equal to -3 times 4 plus a b. So 1 is equal to -12 plus b, and 13 is going to be our b here. So again, now if we were to plug this back in over here, we would get our final answer. I'm going to write this in a different color. Let's do pink. Okay, so this is our final answer, is going to be y is equal to -3x plus 13. This is going to be our final equation for this. And once again, we're just going to go a step further and graph this. So let's just, whoopsie daisies, let's just get that guy out of the way over here. So okay, let's graph it. So let's do this one again first. So we start at +3, that's our y-intercept. So I'm going to do this one in red. Just do this one in red. So 1, 2, 3, 1, 2, 3. So that's our starting point. And so again, it's rise over run. So since our slope is 1/3, now we clearly know that we're gonna go up 1 and 3 across. So up 1, 2, 3, 1, 1, 2, 3, and we can just stop there, and we're gonna put a line through those points. Okay, I got it this time, and let's just make it a little bit bigger. And just as a side note, whenever you're drawing your lines, just make sure they extend to the maximum size of the graph, and don't forget to add these arrowheads as well, so that you know that people know that you're talking about a line and that it's going to infinity. It's not just a line segment. Just do that. It's just math etiquette. So then next we're going to do this one in pink, and again we're gonna start at positive 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4. It's gonna be somewhere up here, but luckily the line's sloping down, so we don't have too much of a problem. So negative 3 over 1. So I'm just gonna do negative 3 over like this way, because it brings us down much quicker. So we're just gonna go down to negative 10. 1, 2, which is up here, I believe. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's right up there, and 1 across. So that's our first point. Negative 1, negative 2, negative 3, and 1 across again. And that's all we need to draw our line. So we can actually do it in just 2, but I'm just doing 3 for fun. So then we're going to draw our line through those coordinates, and yep, that's it, and it looks pretty perpendicular to me. That looks good. It does look perpendicular, and let's just make sure that this line passes through our coordinate 4, 1. So 1, 2, 3, 4, and 1. It kinda does, but I think it's just because I made this line a little bit sloppy. So it's supposed to, though. I guess it'll go something like this, more like it. So yeah, I guess that's just it does almost, but just misses ever so slightly. So that's just a little bit of sloppiness. So just be careful when you do that, because this is generally, it's good to be just exact. So yeah, this is pretty much it, and that brings us to the end of this video, and I hope you enjoyed watching it, and please do subscribe, leave a comment. It really helps me out and motivates me to keep going. So again, thanks for watching, and I hope you found this video informative as well as helpful for anything that you might be doing. So see you guys.